Today's lesson we are going to look at Boyle's law, that is under ideal gases. This is lesson 101. Let us start. We have a number of equations in this chapter, but today's lesson will be based on Boyle's law, which is described by this equation. Now, before we look at the application of this equation, we are going to look at which one describes the pressure and volume. Now, P1, V1, P2, V2. Now, how do we actually apply this? Suppose we have a balloon, and then inside it was inflated with helium, which is a gas. And then it was inflated to a certain percentage or certain volume and pressure. Let's say after inflation we have our volume as 100 dm cube, that is decimeter cube, and then we have our pressure as 50 pascals. Initially we have these values. Now suppose the very same balloon, we increase the volume to 150 dm cube, and then we are actually looking for the pressure. Or we have the pressure, we increase the pressure, and then we're looking for the volume. So this is how we actually apply this Boyle's law. Boyle's law is based on the relationship between the pressure and the volume of an enclosed system. Now, P1 is the initial pressure, V1 is the initial volume, and then after being inflated we have our new volume, which is 150. It will be V2. We can actually say this is PI VI, initial value, initial volume and initial pressure, and then we have final pressure and final volume. We can use this equation to actually calculate the value of the final pressure. Basically, this is how we use Boyle's law. Let us look at examples. Suppose we have this example, a ball which is inflated with the pressure of, or a certain gas inside this balloon. The pressure is 3 kilopascals, the volume is 1200 dm cube, and then the volume is increased to 2400 dm cube, and then what is the value of the pressure? Now we are going to use Boyle's law. P1 V1 is equals to P2 V2. So this pressure is in kilopascals, we need to convert to pascals. Now we know that K is equals to 10 to the power, times 10 to the power 3. So where we see K, we are going to substitute by this. Then we have 3 times 10 to the power 3. So our P1 is 3 times 10 to the power 3, and then V1 is 1200 equals to P2, our V2 it's actually 2400. Then from there we solve for P2, where we are going to divide both sides by 2400. Then this will result into 1. Then P2 is equals to 1500. That is pascals. Now in this particular example, we need to master or know the conversion. Now we can see that our pressure is given in atmospheric pressure. Now we need to convert that to pascals, and then we can see our volume is also given in centimeter cube. We need to convert to dm cube. Now you should know that from centimeter cube to dm cube, we actually divide by 1000, or we can multiply by 10 to the power negative 3. This is the conversion. And then from atm to pascals, you should know that 1 atm is equals to 101,3 times 10 to the power 3 pascals, or you can say 101.3 times actually kilopascals, since this we know that times 10 to the power 3 is kilo. So this simply means that if we have 2 atm, then you're going to have 2 multiplied by 101,3 times 10 to the power 3 pascals. Since we know our conversion, we can go ahead and find our answer. By the way, the question is looking for the final volume, or V2. Now P1 is 101.3 times 10 to the power 3, and then our V1, we need to convert 30,000 centimeter cube to decimeter cube. So we have 30,000 divided by 1000. This will actually get rid of this, and then we actually have 30 dm cube equals to, so we have 2 multiplied by 101.3 times 10 to the power 23, and then we have V2. Now from here we can divide by this. It's actually times 10 to the power 3, not times 10 to the power 23. Okay. 3 both sides. 2 times 101.3 times 10 to the power 3. Then this will get rid of this. And then our V2 is equals to, when we perform mathematical operation, we can see that this will get rid of this, and then you're left with 30 divided by 2, which is equals to 15 dm cube. Now there is lesson 102 of Boyle's law, whereby we look at more complicated questions. This is Bahula SJ. Thank you very much.